Okay, so still question 5. And now on 5b, B1, given the function f of x is equal to 1 minus 2 sine half x minus pi over 6. Okay, find the amplitude, period, phase shift, and the vertical shift, and then sketch the graph. So first find the amplitude, the modulus of -2, which is 2. Period, 2 pi over b, and this is 2 pi over half, which becomes 4 pi. What one? The phase shift, half x minus pi over 6 is 0. So x half is pi over 6 multiplied by 2 multiplied by 2. So we get x is equal to pi over 3. The shift to the right and the vertical shift is 1. And then the scale is going to be p over 4. That is 4 pi over 4, which is pi. So we sketch. So we have pi, 2 pi, 3 pi, 4 pi. Then we start adding the shift. So to pi, we add pi over 3. We'll get 4 pi over 3. To 2 pi, we add pi over 3. We'll get 7 pi over 3. And here we'll get 10 pi over 3. And here we'll get 13 pi over 3. And then the amplitude, we say this 2. So the original graph of sine, since it's negative, it will come this way. Since it's negative. And then we shift now this graph. We shift it to the right by pi over 3 steps. So here also we need pi over 3 from 0. So the first point, let me do this. So here we need pi over 3. So then we start moving. So the first point from 0, it will move to there. Then this point will move there. That point will move there. The other point will move there. And then that one will move there. So our graph is now going to be this. And then you move each point one step up. So we'll go to 1, to 3, to -1. So all the points on -2, they will move to -1. All the points on 0, they will move to 1. Like that. And all the points on 2 will move to 3. And then now we'll draw our sketch, which will be that. It will be that. So it means that we have sketched our graph. Now they were saying you must sketch it in the interval 0 to 2 pi. So you come back and now observe the interval. Okay. So to 2 pi, it must end somewhere here. So you can extract it now and say, okay, since I must end at 2 pi, I know I'll have pi over 3. I'll have pi. I'll have 4 pi over 3 and then 2 pi. So then I have 1, -1, and 3 as my final one. So you can see the graph. We have a point there. We have a point here, and we don't have a point, but it's passing on the negative side of that too. So the curve would go like that, and it ends somewhere there. And so it will continue here up to 3 for it to touch the 0, because it must be from 0 to 2 pi. So this is what becomes our f of x in that manner. You don't erase, you draw another one. Hello.
So I usually get confused. Do you start with shifting, or you first start by doing the scale?
You first list the numbers, meaning the scale. After that, you now bring the original graph of sine, passing through the first 4 important points, starting from 0. Then you now bring the shift. So you shift first either to the right or to the left. Then you shift up or down. Then you go back and look at the range now. Which interval must I give my answer? Here they have said from 0 to 2 pi. So you come here and say, okay, from 0 to 2 pi is here. 2 pi ends here. So the graph must end here. Okay? If I was using a pencil, I would have rubbed this whole thing in red here. I would have removed it. Okay? So I would have come here and said, okay, this one out, out. Then I come back and extend it. And extend it. I just want it to go all the way up to the, just like that. Okay? If I wanted to rub, but I don't want to rub, I would draw it down. So I will leave it. I would have drawn it down, it's here. But I end at 2 pi. Sometimes you can know this point 2 pi by substituting the exact 2 pi in the function. So you say, what is f of 2 pi? It will be 1 minus 2 sine half 2 pi minus pi over 6. This will be 1 minus 2 sine pi minus pi over 6, which is 1 minus 2 sine, that is 5 pi over 6. But you know this is supposed to be what? 180 over pi. 6 there, 3. This is 150. But you know that sine 150. And 150 is the same as sine 30, which is which is half. Okay. So half. So you have 1 minus 2 and then half. So it is 1 minus 1, which is 0. So it must be 0 exact in that case. So we'll take it to 0 now that we have found it. Which must come up. Even the other one, then we are saying 2 pi is there. Meaning that I'll always have to substitute my boundary points. Yes. So that's how you get the final graph. Boundary points are the end of the interval. We are told from 0 to 2 pi. So we are calling these the boundary points. Okay. So,
Sir, sorry, sir. If you are not given the scale, you just do one oscillation.
yes, you just do an oscillation and you end at the shift. So if there was no scale given, our answer would have been this one in red. But because of the scale, it has reduced to the scale given. I mean to the interval given, not the scale. Okay. 2. Prove that sec theta minus cos theta is equal to sin theta tan theta. Excuse. So to prove there, you say, okay, I'll pick the left hand side. That is sec theta minus cos theta. Then change sec. It will be 1 over cos theta. Then you have cos theta over 1. Common denominator is cos theta. And then you have 1 minus cos squared theta, which becomes sin squared theta over cos theta. There are no graphs of cosecant, cosecant. Those graphs are not there in your course. So the sine is squared, so you can write it in this form: sin theta, and then divide by cos theta. Then this one here is tan, so you have sin theta, tan theta, which is the right hand side. So we are done there. Identities are easy for as long as you know how to change from entry given to sine and cos. Even that question which we are solving in the test was still the same thing. C. Volunteer.
So I had a question on identities, but it's fine.
Is it fine?
No, like I had a question, not on this one, but an actual question that I've been trying to solve, but I failed.
You can ask. Perhaps it might be.
Okay. Okay, so you can continue with C as I find it.
Okay. C. Solve each of the following equations. 1, 2, cos squared x minus root 3 cos x is equal to 0. So cos x is common. So first thing is you factor out cos x, and you have 2 cos x minus root 3 is equal to 0. So we have cos x is 0, or cos x is root 3 over 2. Now for cos x is 0, this is only when x is what? When x is 90. Now we are told the answers must be from 0 to 360, so they are degrees. So we know at 90 it is 0, it is also 0 at 270, of course. Then root 3 over 2, this is cos, this is cos 30, cos 30. So x here is 30. But where else is cos positive? In the fourth quadrant. So you go in the fourth quadrant and say, I'm looking for. You go in the fourth quadrant and look for 360 minus 30. So you get 330. So these are your angles. So your solutions are x, 90, 270, 30, and 330. These are the values of x. Like that.
Excuse me, sir. I found the question.
Okay.
So it's 1 minus sine x.
So extra identity.
1 minus sine x
Mm-hmm.
over 1 plus sine x
Mm-hmm.
is equivalent to tan x minus sec x, everything squared.
On the right.
Mm.
So let's start with our right answer. Tan x minus x squared. This is the same as sine x over cos x minus 1 over cos x squared. So the common denominator is cos x. So we have sin x minus 1 squared. But on top there we have sin squared x minus 2 sin x plus 1 over cos squared x. So what we actually, there's no need of expanding the numerator there. Looks like it's already factorized. So just leave it in that manner and say this is sin x minus 1 multiplied by sin x minus 1. Then down here we have cos squared x. But what is cos squared x? So we have this sin x minus 1. Cos squared x is 1 minus sin squared x. So we have sin x minus 1 sin x minus 1 over 1 minus sin squared x, a difference of two squares. So we have 1 minus sin x and 1 plus sin x. Now we want to have this. So on top there we factor out a negative. So we have negative 1 minus sin x, and then the other one will remain the same one, sin x minus 1. Then we divide by 1 minus sin x, and then 1 plus sin x. In this one will go. So we remain with the negative on top, sin x minus 1 over 1 plus sin x. We expand on top there, you have 1 minus sin x over 1 plus sin x, which is the left hand side. Hence proved. Is that okay? Is it satisfying?
Yes, sir, it is.
Okay. Take care, it might come. Anything you see now is very, very important. Okay. So we go to C2, that is 4, 3, 2x plus 1 plus 17, 3x minus 7 is 0. So the first work on this until it gives you something like this inside the brackets. So you have 4, 3x squared, meaning 3 2x. Then you multiply by 3 1, so the 3 1 will be here. Then plus 17, 3x minus 7 is 0. Then 4 times the 3, you have 12. 3x squared plus 17, 3x minus 7 is 0. And then let p be equal to 3 to the power x. So we're going to have we're going to have 12p squared plus 17p minus 7 is 0. Two numbers when you multiply. Hey, what are you multiplying? We're multiplying something big. 12 times 7. What do we get? We get 14 there. 84 comes. And it must be negative. So two numbers when you multiply, you get negative 84. When you add, you get positive 17. It should be 21 by 4. That will be 484. So 1 must be negative. So 4 must be negative. So we have 12p squared minus 4p plus 21p minus 7 is 0. And then pull out 4p, you have 3p minus 1 plus 7, 3p minus 1 is 0. So p is negative 7 over 4, or p is 1 over 3. Now if p is negative 7 over 4, then what is your, remember p is 3 to the power x, so saying 3 to the power x is negative 7 over 4. This is not possible. You cannot have 3 to the power n number giving you negative, unless 3 itself was negative. Then you also have 3x is equal to 1 over 3. This is 3x is equal to 3 to the power negative 1. So x is negative 1. That is your solution for this question there. So this summarizes and ends question 5. So we go to question 6. Evaluate A, each of the following limits. 1, the limit as x goes to 2, x squared minus 4, and x 3 minus 8. First thing here, you know, if you substitute, you get 0 over 0. So you don't even substitute. You go on the numerator and make it the difference of 2 squares as it is. The denominator here, you use 2 to reduce it. So you get 1, 0, 0, negative 8. Then bring 1 down. So you have 2. You have 2, 4, 4, 8, 0. So it's going to be x minus 2 and then x squared plus 2x plus 4. So this part and that one will cancel. So you have the limit as x goes to 2 of x plus 2 over x squared plus 2x plus 4. So you substitute, you get 4 over 4, which is 1 over 3. This question can be asked, they just switch there. So you go through the same procedure, you just be switching also. And the question will guide you, as long as you don't memorize it. So you should try this when you're trying to see what was happening. 2. The limit as x goes to infinity, 3x 3 minus, plus 5 over 5 minus x squared minus 3x3. So already you know that your answer will be 3 over 3, which is 1. But you need to show the working. So you say the limit as x goes to infinity. In the denominator, I'm looking for the highest power, which is x3. So I'll have 5 over x3 minus 1 over x minus 3. In the numerator, I'm taking the same x3 and factor it out there. So I'll have this. So this and that will cancel. And I'll remain with the limit of x goes to infinity of 3 plus 5 over x3. 5 over x3 minus 1 over x minus 3. Versus minus. So you say, then I have 3 over negative 3, which is negative 1. That's all. Not forgetting that the limit as x goes to infinity of 1 over x is 0. This is where you always base your, argument. So it must be something easy to check. Is that a question? Hello. Yes.
Just needs to be fixed. Just needs to be fixed. Like when you have your own house, they just fix it.
Natasha, what about you asking at what happens when what? When what does what? When what approaches what? Okay. Now that is clear the question. Negative infinity and infinity, nothing gets nothing changes. It only changes if you remain with the variable. If you remain with x, it becomes negative infinity. But if there are constants, you still get the same constant. Okay. So we have how many minutes? We still have 8 minutes. So we can do B. B1. Given that y is equal to 5 x squared minus 4 to the power 3 over e to the power 5x. find dy dx. So find dy dx at x is equal to 0. So to find dy dx, you first find the derivative and then you substitute the 0. To find the derivative, you let your numerator be u. So let u be equal to 5x squared minus 4 to the power 3. Then differentiate it. So you drop 3 and you have this to the power 2. Then you multiply by the derivative of the inside, which is 10x. And then v, the denominator. Differentiating the denominator, you just differentiate the power to give you 5, then you multiply by the whole function. Then we are now looking for this over v squared, which is, you can multiply 3, this 3 here, by 10. You get 30x, and then 5x squared minus 4 to the power 2, multiplied by v, which is e5x minus 5e5x multiplied by u, 3, and then divide by e5x to the power 2. You can choose to simplify or you end there. Then now you are asked to find this at what? At x is 0. So you got your answer and substitute x is 0. So when you put 0 here, this whole thing will become 0 minus 5e 50 minus 43 over e50 squared. This will become negative 5 multiplied by negative 4 to the power 3. Because e to the power 0 is 1. So down also we have 1. Now the question is, what is 4 by 4? 16 by 4, 64. And it's negative. So we have positive 64 by 5 to give us a solution. So we have 20, remainder 2, then 30, 32. So it will be 320 as our solution. Then 2, still 5 minutes. Find the equation of the normal to the curve xy plus x minus 2y minus 1 is 0 at the point 1, 0. Expressing it in the form ax plus by plus c is 0, where a, b, c are constants. So you differentiate this using implicity. So you say y when you differentiate x plus x when you differentiate y, but don't forget to put dy dx, plus 1 minus 2 dy dx is 0. So dy dx, and then you have x minus 2 is minus 1 minus y. Divide by x minus 2, divide by x minus 2. So we have dy dx is equal to negative 1 minus y, x minus 2. Then what next? At the point 1, 0, the normal line, so you go first at the point 1, 0, you bring it here to get the mt. So the mt is negative 1 minus the coordinate of y is 0 over the coordinate of x is 1. That, so you get negative 1 over negative 1, which is 1. And you want the mn. And you know that the mn multiplied by the mt gives you negative 1. Implying that since the mt is 1, you're having the mn as negative 1. So now you can form an equation y is equal to negative 1x plus c, meaning y is equal to negative x plus c. So first you look for c. Go back to the point y is 0 when x is 1 plus c, implying that c is 1. So what you have is y is equal to negative x plus 1. Now I've been told that you should express the answer in the form ax plus by plus c is 0, meaning that you write your answer as x plus y minus 1 is equal to 0. So this becomes your normal equation. The equation of the normal line. Normal line equation just. Okay, so we are okay. So 5 minutes, then we'll walk back and continue. We are almost done. Come back to do 6C and question 7.